This is easily one of NASA's greatest accomplishments in planetary exploration. This rover weighs 1 ton. It has a payload on board which is about 15 times as heavy as the science payload that's ever been sent on any previous Mars rover.
Moving beyond Earth Gallery for a very special program on the Mars Curiosity rover landing last night.
Okay, this is Curiosity right here.
Geologist Ross Irwin will bring you up to date on Mars Science Laboratory. Join us to watch a press conference at JPL.
You are already ahead of the game here. So this is the 1997 Sojourner rover that was sent up on the Mars Pathfinder mission. There's a couple of people here for scale. In 2004, we launched 2 Mars exploration rovers, and you can see that they've gotten considerably bigger than the Sojourner there. The Mars exploration rovers were solar powered. 2 of them were launched, landed in 2004. One of them, Opportunity, is still operating and still returning good science. For the Mars Science Laboratory Curiosity, there was only 1 sent up. You'll notice there are no solar panels on it. It is nuclear powered, and it's considerably bigger than any previous Mars rover. There's a long story behind the history of water on Mars, and this is something that the Curiosity rover is being sent to investigate. Since the early flyby missions in the 1960s, we've known that Mars has many impact craters on the surface, and in that sense it looks something like the moon. The Earth has been bombarded by impacts very much like this over time, but because of plate tectonics and erosion, many of those impacts have been eroded away. Mars records a surface that reflects the earliest history of the solar system. But when you look at these impact craters on Mars, you can see that they've been eroded. They don't have a fresh appearance here, and in between these craters there are networks of little river tributaries that flow into craters here. Some of them flow out the opposite side, suggesting that there may have been ponding in craters, and ultimately the water, in this case, flowed downhill into this larger crater called Gale, and that's where MSL is today. We very often will colorize images of Mars to show you what's up here. The warm colors here are high elevations, and then you go downhill toward the cooler colors here. MSL has a very wide range of mission objectives. It is the first mission since the Viking landers of the 1970s to actually look for the chemical building blocks of life. Carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. This is the stuff that life is made of. They're going to be looking for organic carbon compounds, the effects of biological processes. They're also going to be looking at the geology of Mars, at the chemical, isotopic, and mineralogical composition of the surface, the processes that form and modify the rocks and soils. They're going to be looking at the evolution of the atmosphere over the past 4 billion years, and look at how water and carbon dioxide are being cycled from the surface to the atmosphere and back. They also have an instrument on board which is looking at the surface radiation environment, which will give them a sense of the hazards that astronauts will face when they land on the surface of Mars at some point in the future. That spacecraft looks very much like this illustration here, where you can see all these instruments labeled. MSL has a total of 10 major instruments. They cover a wide range of science objectives. The mass camera here stands up about the height of the human eye. There are 2 cameras there, so you can see in stereo and have depth perception. The ChemCam instrument is a chemistry instrument. The radiation assessment detector tells about the radiation environment. The chemistry and mineralogy instrument, sample analysis at Mars, is a very complex instrument internal to the spacecraft that studies soil samples. The DAN instrument was contributed by Russian collaborators, and that one tells you about the hydrogen in the subsurface. The Mars Descent Imager is a camera that was taking pictures last night as the spacecraft landed on the surface. The hand-led imager gives you a close-up look at rocks. It's mounted on the end of the robotic arm out here in front. The APXS is a Canadian instrument, also contributed by international partners. And then the REMS instrument is the weather station on MSL, and that was contributed by Spain. The landing site here is Gale Crater, and Gale is about 100 miles in diameter. This was formed when a very large asteroid struck Mars about 3.7 billion years ago, give or take. And you can see up here this little oval-shaped area This is MSL's landing ellipse. This is the smallest landing ellipse that we've ever had on Mars. The engineers can tell us within 99% certainty that they were going to land in that area, and it looks like they did. So previously, the error involved in landing on Mars was much bigger, and you could not safely land a spacecraft in Gale Crater, but now we're able to do it. This big science target in Gale is this mountain of layered rocks here in the middle of the crater. So they're going to be driving from the ellipse off to the south and climbing a mountain with this rover. Over time, they've been able to take their landing area and shrink it down from about 12 by 15 miles to an area that's about 12 by 7 miles in size. And so they've been able to hug up closer to this main science target. And from there, they're going to drive off to the south and climb the mountain. This gives you a sense of what the original landing ellipse looked like. There has been some erosion of the northern rim of the impact crater, depositing sediment down here inside the landing ellipse. They're going to drive off to the south, and they're going to climb up this layered sequence of rocks here, looking at clay minerals that are deposited near the bottom, sulfates that are deposited a little bit higher up. And as they climb up this mountain, they're going to be looking at these layers of rock, reading them like pages in a history book, and telling about the geology of Gale Crater. Older deposits are on the bottom, and then younger deposits are on top. So as they climb up, they're going to be looking at progressively younger and younger rocks. Ultimately, they're going to get up to some of these heavily wind-eroded rocks up here near the top of the crater stack. And so now I'm going to show you what Curiosity did last night. This is easily the most complex entry, descent, and landing sequence that NASA spacecraft has ever gone through. And it starts with the Atlas V launch vehicle, upper stage Centaur, boosting MSL onto the interplanetary trajectory to Mars. And then they point the thing in the right direction, and they spin it up to 2 revolutions per minute. And what this does is it keeps the spacecraft pointed in the right direction without having to use a lot of fuel as it goes on. So now the upper stage Centaur booster is jettisoned, and you have the entry vehicle here and the cruise stage on the back of it. The cruise stage is solar powered, and it also has fuel on board, which provides the propulsion for trajectory correction maneuvers on the way to Mars. So you don't have to basically fire this thing off from the Earth and hope you hit the target. They actually do have the ability to tweak the course along the way and do some course corrections. The part in the middle is sort of boring. That's 8.5 months of waiting and measuring solar flares along the way. Ultimately, what happens is you have what they call 7 minutes of terror. This is where MSL enters the Martian atmosphere and has 7 minutes to slow down from 13,000 miles an hour to nothing as it reaches the surface. The reentry vehicle provides a little bit of lift, and it's able to execute a series of S-turns, very much like the space shuttle did as it came into the Earth's atmosphere. And this is what allows the precision-guided landing onto the surface. There is an ablative heat shield, which dissipates the heat of reentry as the entry vehicle is coming into the Martian atmosphere. This is very, very hot. You notice there are 8 thrusters on the back of the back shell there, which are providing the control and stability. Now, you're still moving at about Mach 2 here, and then, despite that speed, they pop a parachute. This is the disc gap ring type parachute, which is able to open up at very high velocities. As you come down, though, the Martian atmosphere is very thin, and if you were to come down just on the parachute, you'd hit the surface hard. So you have to have descent thrusters kick on, and MSL is then slowed down considerably from the high speed of the parachute descent, now down to a soft landing on the surface. This thing is called the Sky Crane. This is something that we've never used before. It was designed to provide a 1-ton payload capacity to the surface of Mars, and that's about what MSL weighs. So here we're slowing down, and in order to provide that soft landing, they're going to lower the Curiosity rover down on the end of a long cable. And as they're doing this, they're taking pictures of the ground so that they know exactly where they land. And there it lowers down. The wheels pop into place, so the wheels are deployed when it lands. And then they come down very slowly and softly and set Curiosity down on the surface. And a lot of people were worried as to whether all this stuff was going to happen, and it seems to have, because we got some great pictures. Now, after executing this soft landing, this piece right here flies off and crashes. This is more or less what Curiosity looks like right now. Its mast has not been deployed yet. There are some cameras on the front and the back of the rover here, which are providing some early images of the surface and just giving them a little bit of a sense of what may happen to be around them. When you look at these images, this is what we get. This is from the rear hazard avoidance camera. This is Curiosity's back wheel. This is its power supply here. And this is basically just a proof of life type photograph. You look at this and you see that it seems to be in pretty good shape, and that gives them some confidence that the thing actually did come down softly. The material here on the ground doesn't seem to be too rocky. It's this sort of sand, a kind of fine gravel size range. We may hear a little bit more at the Jet Propulsion Laboratory press conference at noon about the first impressions of this site. And Curiosity also took a picture of its shadow. The science result of this is that we'll have 6 more weeks of winter. And then at 12 p.m., we'll have the NASA JPL press conference. That'll be in just about 4 minutes. So if anybody has any questions, I'd be happy to answer a few questions between now and then.
You said the first rovers that we sent are still giving off information, are still sending back to us. Are they mobile as well, or are they stopped and dead?
So the question is, the earlier rovers that we've sent to Mars, are they still working? And the Pathfinder Sojourner rover is not still operating. We had 2 Mars exploration rovers, and one of them is still operating. Those rovers were designed to operate for 90 days, and one of them is about 8 years into that. So it's they're doing Opportunity's doing very, very well. Yes, here in front. The question is, how long is Curiosity going to be functioning and collecting data? The nominal mission is for 1 Martian year, which is 23 months. But I think everybody hopes and expects that it'll last a good deal longer than that. Yes, ma'am. And the question is this a different region than what we've explored before? And yes, it is. We have, in earlier missions to Mars, we've been able to look at only just a few meters, a few yards thickness of stratigraphy. And now we're going to be able to look at this mountain, which is 3 miles high. And all of that is just one layer after another. And so they'll be able to look at just a vastly greater geologic record on Mars than what we ever have been able to before. Sir? The question is, how close did Curiosity get to the center of the landing ellipse? And I don't know the answer to that yet. In the JPL press conference, we may or may not see a little more precise idea of exactly where it came down. Yes? So the question is, when is it going to start moving? So what Curiosity is going to do next is focus on a series of engineering tests, and there will be some science data collected during that time. We may get a little better sense of what their plan is during this press conference, but you'll see over the next couple of months a transition from more engineering operations early to more science operations a little bit later. But they do have to do a lot of engineering checks as they go forward. Yes, ma'am. How many people are involved? Thousands. The science team is about 400. And you've heard the expression herding cats. Well, I mean, that's basically what's involved there. But it's just many thousands of people are involved in pulling off something like this, not just on the science side, but on the engineering side and program management and it's really an enormous effort. Yes? So the question is, what happens to the sky crane after it drops Curiosity gently onto the surface? And it does just fly off and crash. So it's essentially a piece of wreckage somewhere. The heat shield also drops away, the back shell and the parachute drop away. So whenever you see a Mars landing site, when we have these high-resolution images from orbit, these spy camera pictures we take of Mars, you can actually see all of these pieces that come down up and around the landing site, and they just lay there. Yeah. Okay, yes. The question is, does NASA ever plan to pick up those pieces? No time soon. That would be that.
Here.
Yeah, well, that's right. And the Air and Space Museum, I think, would have first dibs on those if we ever did get them. It would cost a lot more to bring them back than it ever did to send it there. Yes, sir. Who built the rover? The rover was built at the Jet Propulsion Laboratory in California, which is a NASA Caltech center. And the rover mission is operated out of there. So the people who are working on this mission right now at JPL are switching over to these 24-hour and 39-minute days, which is it's really a tough way to live, but that's what they're doing. And so every day your day gets staggered a little bit more. Yes. How often does it send back images? Every day, normally. And so, okay, we have it up? Okay, I guess we have the press conference over here. Okay. Okay, so we're going to transition over to the NASA Jet Propulsion Laboratory press conference, so you'll be able to get this news directly from the source. So thank you all for coming out here and being with us today, and we hope you enjoy what you look out.